Okay, this is my personal AWS account. As you can see, this is me right there. So what I've done here, I spun up a simple, a very small EC2 instance, T2 micro, because this is very basic POC. And I created this EC2, which has, I call it control server basically, because it has everything that I need to provision resource and deploy application to the cloud. So I installed Ansible, I have Terraform, and also I have Azure DevOps agent configured there. This is, I'm not going to go through that because the process will a little bit involved. So to make this POC as quick as possible, to show you how the pipeline works and how we can deploy apps and provision resources. So we're just going to make this short, and then we can always go back and show you the whole process, everything that I've done. One more thing that I'd like to add here is, here we go. Not EMI. I'm looking for, here we go, the IAM role. Okay, so what I've done here, I create an IAM role and I attach it to this EC2 instance. Basically, the purpose of that is this role is going to assume access on my behalf, and what this is going to help me avoid embedding code, embedding password and secret keys within my code, right? So that's something that's definitely we have to avoid. And there are a lot of ways. So you can use variables, you can use some encrypted ways to encrypt secret keys and all that. But this is one of the best ways to do that because I keep everything on the server level, and since nobody has access to server, so I'll let the role work on my behalf, and I'll show you the code that basically has no password, no user ID, or anything that is sensitive embedded within my code. Now let's go back to Azure DevOps and go through the process. I am on my Azure DevOps UI. I have two projects here. I can create as many projects as I want. As you can see here, I create one. It's called EC2 TF EBS, which means I'm creating EC2 instance using Terraform and attaching EBS volume. I tend to use the naming that makes sense to me because this way, if I have too many projects, I can tell exactly which one does what. So this does, basically it tells me exactly what it does. Creating EC2 using Terraform and attaching EBS value. Anyway, let's go to the repo. Okay, this is basically a simple template or playbook, call it whatever you want. This is a Terraform. You can see extension is .tf. I can go here. Quickly, I want to show you that there is no code embedded here. I'm sorry, no password embedded here. This is actually commented out. Let me just go down here. See, as you can see, access key. It's a calling the variable. There's nothing here that's hard coded. I'll show you the variable, and I'm saying I'm using for the latest version 14.5 or maybe closer to the latest. I'm using a strip bucket because I want to save my state file. Terraform uses state file, which is really a nice feature. If let's say I provision today an EC2 instance, 3 months later I want to add a load balancer. So I can use this state file, and it's smart enough to resume the work. In other words, I can call the whole template here, and Terraform knows that this EC2 already been provisioned, so it's not going to provision another EC2 for me. However, if I add, let's say, a load balancer here, it will pick up the load balancer. So it does incremental work. It does, which is really nice if you have a multiple project. It's a really nice feature to maintain your project. So I go back down here. As you can see, this is the end of, as you can see, um, this is the my instance parameters here. Um, Basically, I have an EMI, which I'm going to show you. I just use an EMI from the marketplace, the instance type. So all these are variables. There's nothing hard coded here. Okay, this is the volume. That's I'm saying, okay, give me GP2. We can change it to SSD or any type we want. This is the EBS, as you can see. This is EBS, and this one is the root volume, right? The difference between the two. A root volume is it gets provisioned by default when you spin up an EC2. EBS is, let's say you need more space, you can attach an extra EBS volume with 20 gig, 30 gig, or whatever the request is. So that's basically what I would like to show. There's no code, no password that's been embedded. Let's go back to the variables. Okay. Again, see that access key? Nothing. It's blank. Okay. Secret key is blank. Region, yes, we need to tell which region we're going to spin up this EC2 on. So let's see, this is just the tag name. Instance, this is the count, how many instances we want to provision. By default, I just use one, but we can still spin up 2, 3, 5 instances in parallel, which is nice. So we don't have to do one at a time. And let's see the AMI ID. This I just grabbed this from Marketplace, or you can go to the EC2 dashboard and grab an AMI from their AMI ID. So I'm using this AMI as a base. Okay. And instance type, I'm just using a T2 micro since this is a simple piece POC. The key, I'm just using the key name. I'm not using not this is just a key name that I already have on my AWS account. Let's see what else. That's it. Subnets. We need to tell which subnet we're going to be using. The root volume here. Here's the size. I want 10 gig, and the EBS volume 20 gig. We can change that to any, and the rest here is just it's all commented out. Few parameters I was testing with. That's basically that's it. Now we are ready to run this playbook through the pipeline. Okay, let's go back to the pipeline. I can go to the releases here. This is the release I was working testing with. So I call this dev EC2 EBS pipeline. Basically, you can have as many pipelines here as you want, and it's good to differentiate the two. If you're using stage, you call it stage dev whatever, or using prod, you call it dev EC2 whatever. This way you know which one is which when you try to provision or destroy resources. So you want to make sure that you're not um, destroying something in production by accident. So it's good to use the prefix that tells you exactly which environment you are going to be working with. So let's go back here to edit. So this is my pipeline. It's a simple pipeline here. This is, I'm telling it, grab my code from the Git. This is EC2TF EBS Git. This is the source. Um, Basically, if I go back here, I'll show you what I'm talking about. Where is my, actually, let's go back to my repo. Let's open another tab. There you go. There you go. You see that? These are my branches. I can have as many branches. So the branch that I'm working with is called EC2TF EBS. Okay. So I go back here. So this is my pipeline. I'm gonna go to task. What are the tasks we have within this pipeline? I had a few tasks here, but I was just testing the process. I can have TF in it. Here it has this is disabled. I can right click and enable it if I want to. The only one is enabled is this one. What I've done here, I created a job that basically runs everything in one job. I have Terraform in it, which downloads Terraform artifacts and the binaries, and then once that it's done, I run Terraform plan. Basically it shows you what is gonna what Terraform is gonna provision. So you get an idea exactly if you're building EC2 instance, it shows you everything that it's about to get provisioned. It's a good way to see and validate before the apply is executed. And then the last process is Terraform apply, and it would provision the EC2 instances on the cloud for you. Okay, that's basically what I would like to show you. Again, I put everything into one job. You can, if I click here, I have init here. You can have it, you can create separate jobs. Like here, same thing. I have apply, but since this is a simple pipeline, I just create everything into one job. The other challenge I've seen in my prior project is some DevOps team tend to use their laptops to provision resources to the cloud and deploy application to the cloud, which it works. The solution works because you as an admin you provide them with the key, secret key. You create an IAM account and you give them the IAM account information, right? And then they use that to configure their AWS CLI, and then they can start provision deploying resources to the cloud, right? But the challenge is, what if the person is sick, right? What if the person is on vacation? What if the person leaves the company? Then what? We have to start all over again. We have to reconfigure and set up the whole process again, which can take time. So let's say today we have a request. We need to get this request, done in next hour or two. And if we don't find the person who's going to provision this for us, then what? You have to set up the whole thing. It can take you hours to set up the whole process. Whereas here, I have my job already here. It's already set up. I've tested it and validated. Everything looks good. Then if I'm not around, anybody on the team can come in here with access to this UI and can come in to this pipeline and run it for me on my behalf. So it's really a good way to do things more efficiently. It's a good way for the team to collaborate from one central location and get things done rather quickly. Okay, now we are ready to run our pipeline. Okay, so before I do that, let me go to my AWS account just to show you that there is nothing here is running except my control server. That's my server here. But in a minute or so, we're gonna see another EC2. It's gonna be provisioned from this UI pipeline. Okay, I just want to show you that there's nothing there. Let's go back here and let's run this pipeline. Since everything else is disabled, you see this line across all these jobs. So the only one that is going to be executed is this job. Okay, so to do that, I'm going to create a release, run that, and it says put description. This is good if you have multiple teams are running the same job, so that you see who's doing what. I'm just going to say EC2 team 1, something like that. Okay, and the create, and now let's monitor the logs. Here we go, the job is running. I can hover here and then click on logs, and it's connected to the agent on the EC2 server, control server, and now it's running our job. It finished downloaded the artifacts. Now it's doing the let's see, it did the plan, and next it's gonna run the create, the apply. It's doing the apply here, Terraform apply. So it's provisioning the EC2 instance as we speak. Let's go back to my account and see what's going on there. Let me refresh. Here we go. It's pending. So the pipeline is doing what it's supposed to. So it is creating our EC2 instance. I called it EC2 POC. So this is a tag name. You can call it any name you want. And let's refresh again. Let's go back here. It is initializing. So the job has run successfully, but it's not quite done yet. It's still initializing. Okay, let's go back to my pipeline. Here we go. The job finished. The plan init apply, as you can see here, succeeded. Everything looks good. Now let's go back to my accounts, refresh. Still initializing. Okay, if I click here, just let's expect to see what we have here. Let's see, we have a public IP. It's already been assigned to it. VPC ID, the subnet, AMI ID that we used as a base. Let's see what else. Here's my key pair. If I want to access this instance, I need to download the key and SSH from there. So it looks good. Let's see what else. Oh, so yeah, here's my EBS volume, the extra EBS volume that I created. Matter of fact, if I go back here under volumes, here we go, and we should see two EBS volumes that were created. Here we go. Let me just expand this. Here's my POC. This one is the 10 gig. It was the root volume, and this one is my the 20 gig is my extra EBS volume. So it looks good. Let's go back here. Let's refresh because this is still initializing. It's still initializing. So I'm gonna pause here for a second till this finishes, but everything looks good. Okay, my instance here, my EC2 instance is up and running. It has been provisioned successfully. As you can see here, the status check passed. Everything looks good. If I go to the volumes, I see my two EBS volumes, the root 10 gig here, and the other one is the extra EBS 20 gig. So please make a note here. As soon as I terminate this instance, these two volumes will get deleted as well. So in order to terminate this instance, I have two options, right? First option, I can do it right from here, from the console. Click on instance state and come down to terminate instance, right? The second option, I can terminate this instance from the pipeline, right? Remember, the goal here is to basically provision and maintain resources from the pipeline. So we want to avoid using the console as much as possible. So I can, if I created an instance from using the pipeline, I can also destroy it from the pipeline. Okay, which I'm going to show you in a second. Let's go back to my pipeline here. So here I have this job, it's enabled. So since this job is already done, I'm going to go ahead and disable it, right? And I have a job already set up here. It's destroy. I think these are the same. I can go ahead and enable this job, right? So what am I doing here? Basically, I'm running the init, and next thing, the init is just initialize Terraform, and next thing I'm gonna do Terraform destroy. And this parameter auto approve is basically, it's not gonna wait for me to say yes or no. It's not gonna prompt me. It will just go ahead and destroy it, right? Okay. So let's do that. One question, actually, this might come up. You may ask me, well, how this Terraform, it's gonna, let's say we have 10 EC2 instances on my account. How this job is gonna know to destroy that particular EC2 instance and not accidentally destroy another instance. Okay, this is a valid question. Well, let's go back to my repo right here, and let me make sure I save. So this is, remember a few minutes ago I was talking about the state file. Let me just show you what I'm talking about here. If I go back to, I believe it's in the main. Here we go. Remember, I saved my Terraform state file on this bucket. The bucket is called right here. The bucket is 24/7 dev. Okay. Now let's go back to my account. Okay. Let's type AC3 S3, and we should be able to see whether our state file has been saved and created for us. Okay. Here we go. You see that 24/7 dev, and under 24/7 dev, we should be. And I remember I have like a subdirectory, a bucket subdirectory, 987, and here it is, terraform.tf state. Okay, March 30th. That's actually just today. I did this when we created the EC2 instance. So the point that I'm trying to make here is when I do destroy, um, let's go back to my pipeline. When I do destroy, Terraform knows that it's going to use this particular state file in order to destroy my instance. It knows, it knows exactly which EC2 needs to be destroyed based on that state file. Okay, so let's go ahead and run the job. Make sure everything is disabled here. Okay, so the only job that is enabled is a TF destroy, which is this job here. And destroy. I'm going to go ahead and create a release. Just say EC2 destroy, and go back here and create. Go to my logs there. The job is running. Let's go to the logs and see what it's doing. Okay. Okay, the job has been initialized, and now it's going to start terminating my EC2 instance. Let's go back. Let's go back to my account, and let's refresh. Here we go. You see that the EC2 instance is shutting down. Let me expand this so you can see that. Here we go. It's shutting down. And usually that's the sequence of the process. It shuts down you see that, and then terminate the process. So it shuts down the instance, then it terminates it. Okay. So if I refresh again, okay, it's gone. So my only instance here is my control server. And if I go to my, remember we had two volumes. Let's click here, volumes. These two volumes are gone. Okay. Remember, I had two of them. They're both called POCs. They're gone. These volumes here, they are from my other POCs that from these instances. So yeah, the job is done. We were able to create it successfully, and we were able to destroy it successfully, all from the pipeline.